So the first we see, I told you to join early only, right? Okay, first we starts with the in this covariance concept. We need to start the what is the meaning of this covariance. After that, we go for a definition of this covariance. Then we have some important theorems regarding the covariance concept. Then at the end, we'll go for examples on this covariance concept, right? So first we go for what is the meaning of covariance, right? So what it tells us, or what is the use of that uh, covariance, right? So here meaning, right? So covariance is a statistical measure, right? So what it is it is a statistical measure. Then what is the measure means? We are able to find out that value, or uh, we are going to identify that value. How? With the help of some basic tools of statistics. So that's why this is called, the covariance is a statistical measure, right? So it measures what? It measures the change of two random variables, right? Is it clear? So how two random variables, how two random variables change together. How this two random variable change together? It means that what? It measures the linear relationships, right? It measures the linear relationships between any two random variables, any two uh, any two random variables. Is it clear? So this is the meaning of covariance. Covariance is one of the statistical tool. How we have mean, how we have median, how we have variance. Like that, we have covariance is one of the statistical measure. Then what it does the, or it measures the change of variables, right? Say for example, suppose we consider, right? So X is investment on ad or ads, right? So X is another one, investment on ads. Then what about Y? Y is revenue of product, right? So here X is nothing but some amount we are investing for the ad making or promotion of that product, and Y is the revenue generated by that product, right? So then, so my question is, are X and Y are dependent? X and Y are dependent or not? Obviously, yes, right? So at what strength they are dependent, that can be given by correlation concept, right? Not covariance. That can be given by correlation. In further study, we are going to study the correlation concept also. But to study the correlation, we need to completely understand the concept of covariance, or complete meaning of covariance, right? So once again, I repeat, covariance is a statistical measure. It measures the how two random variables changes together, or it indicates the direction of linear relationships between the random variables, right? If X and Y are two random variables, what about the linear relationship between X and Y? If X increases, what about Y? Or if Y increases, what about X? So like that, to find out the relationship between any two random variables, we can use the covariance concept. This is what the meaning. So now we'll move to the second concept in covariance, that is definition, right? So here, second one is definition of, sorry, definition of covariance, right? So here let x comma y be a random variables. Let x comma y be random variables. Then covariance between, then covariance between x and y denoted by COV, right? This is nothing but covariance, first three letter of this covariance between of any two random variables. So that is denoted by covariance of xy and is defined as, covariance of x comma y is equal to, I think you might be studied the concept of covariance in descriptive statistic, that is and this covariance is same, but the method of approaches are different. It is in terms of expectation, and whatever you studied, that is in terms of only descriptive statistic, right? There I think you use the formula like n into summation xy minus summation x into summation y, like that. I think you used the formula that is come under descriptive statistics. But here covariance is given by expected value of x minus expected value of x minus expected value of x into y minus expected value of y whole expectation, right? So this is what the definition of covariance, right? So covariance is given by this formula, that is nothing but x minus expected value of x multiplied by into y minus expected value of y for this whole expectation, right? So this is what the definition of covariance. Clear? So now we completed meaning, definition. Now we go for some theorems. So theorem first, prove that covariance of x comma y is equal to expected value of xy minus expected value of x into expected value of y, right? See, whatever we have this formula in a definition, right? So for calculation purpose, it may be difficult, right? For computational purpose, we can use this formula also. Prove that, I mean this formula, covariance between x and y is equal to expected value of xy minus expected value of x into expected value of y, right? So now we are going to prove this, proof, right? So by the definition, we consider the same, whatever we had definition, by the definition of covariance between x and y. So what our definition says, definition is nothing but covariance of x comma y is equal to x minus expected value of x into y minus expected value of y for this whole expectation, right? So which is equal to, now expectation outside, this is as it is. So now we'll take product, right? So x into y, this is xy, right? Next, x into minus value of expected value of y. So this is minus expected value of y, but here multiply x is there, right? Next, minus x, sorry, minus expected value of x into y. This is nothing but minus y into expected value of x. Next, minus times of expected value of x multiplied by minus times of expected value of y. So that will be plus expected value of x into plus, sorry, into expected value of y, right? So here, So I hope from how we got it, I think it is very clear. Now apply this expectation inside the square bracket. So this will be expected value of xy minus expected value of x, expected value of y. So again, minus expected value of y, expected value of x, right? Next, plus both are numeric answer. So expectation of constant is a constant only. So we'll take the same expected value of x into expected value of y. Now, what are the remaining things? See, minus expected value of x and these are get cancelled or not? If you observe clearly, right? So minus expected value of x into expected value of y. Okay, here, not this, plus expected value of x and this one. So these two terms get cancelled, right? So now whatever we have the remaining things, expected value of xy minus expected value of y into expected value of x. Clear? So here it can be rewrite as like this. Expected value of xy minus expected value of x into expected value of y. So this is what the right side we have covariance of xy, right? Clear? So this is a very small proof and easy proof, right? So that is nothing but covariance of xy is nothing but expected value of xy minus expected value of x into expected value of y. Now we have next theorem. See, those who joined late, we are discussing the covariance concept and we discussed meaning as well as definition of covariance. Now we are discussing the theorems of the covariances, right? So second theorem, prove that covariance of ax comma by is equal to a into b covariance of x comma y, where a and b are any two real constants. It means that a and b are into real numbers, right? So now at that time, the covariance of ax comma by, right? This is equal to covariance of ab, sorry, not covariance of ab into covariance of xy. So now again, we are going to prove this. Same, we are using by definition. So what we have definition? Covariance of x comma y is equal to x minus expected value of x into y minus expected value of y for this expectation, right? So instead of x, what we have? Ax. Instead of y, we have by. So accordingly that just we need to change in the formula. So covariance of ax comma by is equal to expected value of, instead of x, what we have? Instead of x, we have ax minus expected value of ax. Next, instead of y, what we have? by minus expected value of by. Clear for this? Clear. So now we know that expected value of ax is nothing but a into expected value of x. So covariance of ax comma by is equal to expected, this is outside expected as it is, ax. So minus a into expected value of x because of this, right? Next, by as it is. So this will be b into expected value of y because of same, right? It means that expected value of ax is nothing but a into expected value of x. This is nothing but expected value of constant multiplied by random variable, that will be constant into expected value of that random variable, right? So here what we'll do, in this common, in this quantity a is common and in this quantity b is common, right? So expected value of a into x minus expected value of x In this, b is common, b into y minus expected value of y, right? So a and b are any two constant. So again, we can take outside the expectation operator. So a into b, expected value of what are the remaining things? X minus expected value of x, y minus expected value of y. So this is nothing but a into b. So this is nothing but our definition exists. So this is nothing but covariance of x comma y, right? So this is one more simple proof. Covariance of ax comma by is nothing but ab into covariance of xy. So now we'll move to the next third theorem. Prove that covariance of x plus c comma y plus d is equal to covariance of xy where c and d are same, any two real constants, right? So I think here in a previous slide, the numerical examples will be like this. So what is the covariance of 2x comma 3y? This is nothing but what? A into b covariance of xy. To find out this, it is sufficient to find out only covariance of xy, then multiplied by 6. This is nothing but 6 into covariance of xy. Why? Because we know by this theorem. So next theorem will be like this. If how to find out the covariance of x plus 2 comma y plus 3. This is nothing but covariance of xy itself. So just we are neglecting that plus 2 or minus 2, whatever it may be, right? So for that, we have the proof. Proof. Same here also, we are using the definition of covariance. Covariance of xy equal to expected value of xy minus, sorry, we are using this here, expected value of xy minus expected value of x into expected value of y. So why? Because of this first theorem. Which theorem? Here we shown that covariance of xy equal to expected value of xy into, sorry, minus expected value of x into expected value of y. So by this theorem we can write here covariance of xy equal to expected value of x into y minus expected value of x into expected value of y. Same, replace here x by x plus c and y by y plus d. So covariance of x plus c comma y plus d is equal to expected value of, instead of x what we have, x plus c, right, multiplied by y plus d minus expected value of x, this is expected value of x plus c into expected value of y plus d, right? Instead of x and y we replaced x plus c and y plus d respectively. Now again there are two terms, multiply, expectation will be outside here, x into y, xy plus xd plus cy plus cd minus, here what we have, expected value of x, we'll take minus outside here, expected value of x plus expected value of c into expected value of y plus expected value of d, right? So now here apply the expectation inside, expected value of xy plus d into expected value of x plus c into expected value of y plus expected value of c into d. Now minus expected value of x minus expected value of c, right? And here here it is multiplication, right? What we should take, just wait. Just wait here. So it will be like this, right? Expected value of this minus will be common here. This is nothing but like this. Here also product, right? Now we go for this. Expected value of xy is expected value of xy plus wherever we have random variable, there we can operate expectation. D is a constant plus cy. Next plus expected value of c into d, right? So now as it is minus expected value of xy, see here expected value of x into expected value of y. Next what we have, this one completed, this one plus expected value of x into expected value of d here. First we took this, next we took this. Now this one plus expected value of c into expected value of y into this plus expected value of c, expected value of d. So here this minus is completed. Now expected value of xy plus d times of expected value of x plus c times of expected value of y. CD is a constant, right? So here c and here any two real constant. So expectation of any constant is nothing but constant only here. So in here c into d. Now minus expected value of x, expected value of y. Why? Because this minus will multiply inside. Now minus d into expected value of x, y. Expected value of d is d, expected value of x is same. So multiplied means d into expected value of x. So minus outside is there, so minus here. Next minus c into expected value of y. Why? Because minus c expected value of y. Now minus cd here. Why minus cd? Expected value of c is c, expected value of d is only d. So now here some terms are going to get cancelled. So just to observe which terms are going to get cancelled. Plus cd, c into d minus c into d. Plus d into expected value of x minus d into expected value of x. C into expected value of y plus minus c into expected value of. So now remaining things. See in the right hand side what we have? Covariance of x plus c comma y plus d equal to, here what we have? Expected value of xy minus expected value of x into expected value of y. So this is nothing but what? Simply covariance of xy only, right? Is it clear? This is what the theorem. The theorem says that covariance of x plus c comma y plus d is equal to covariance of xy. That is sufficient. So now we'll go for next theorem. Fourth one. Prove that covariance of the same random variable, covariance of x into x, this is nothing but variance of x. Covariance of x comma y is nothing but variance of x. Now we're going to prove this theorem. We know that, what we know, expected value of xy minus expected value of x into expected value of y. This is nothing but covariance of x comma y, right? So covariance of x comma y is nothing but what is expected value of x? Expected value of x into x, because y is replaced by x only, minus expected value of x into expected value of x, right? Sorry, here x. Now covariance of x comma x is equal to expected value of x square minus expected value of x whole square, because there are two whole squares. So covariance of x comma x is nothing but, this is nothing but our variance formula. So covariance of x into x is nothing but variance of x, right? Only usually such small theorems we usually will ask for 2 marks, right? So show that variance of x equal to covariance of x comma x, or prove that covariance of x comma x equal to variance of x, like that we are going to ask in exams. Clear? So just I will recapitulate here up to theorems now. See, first we started with the meaning of the covariance, right? What is my covariance? So we started the covariance concept today. What do you mean by covariance? Covariance is statistical measure which shows you or which gives you the interrelationship between the two random variables. If one increases, another one is increases or decreases. If another decreases, another one variable is increases or decreases, can be explained by the covariance concept. Next, the definition of this covariance is here. Covariance definition is, let x comma y be a random variables, I mean bivariate random variables. Then covariance between x comma y is denoted by COV, open bracket x comma y, close the bracket. This is the notation to find out covariance of x comma y, and it can be defined as by this formula. That is covariance of xy equal to expected value of x minus expected value of x into y minus expected value of y. After this, we go for, we discussed the first theorem, that is covariance of xy equal to expected value of xy minus expected value of x into expected value of y individually, right? Next, after that, the second theorem is covariance of ax comma by equal to ab into covariance of xy. Third theorem is covariance of x plus d comma y plus d equal to covariance of xy. Then fourth theorem is covariance of x comma x equal to variance of x. So now whatever we discussed up to here, I will just summarize. Summary on covariance. Summary on covariance. First point. So covariance of x comma y, covariance of any random variable is given by expected value of xy minus expected value of x into expected value of y. Next, second, covariance of x comma y is equal to 0, then what it indicates, right? So this, whenever covariance are 0, we can't say that x and y are independent, right? It may be dependent or it may be independent. It means that does not imply that x and y are independent. See, if x and y are independent, if x and y are independent, this implies covariance of xy equal to 0. But covariance of xy is 0 does not imply X and Y are independent. X and Y are independent. It means that reverse is not be true. Means it may be true, it may not be true, like that, right? If they are independent, yes, obviously covariance is zero. But if covariance is zero, we can't say that X and Y are dependent or independent. Third point, covariance of AX comma BY is equal to, already we proved, that is A into B covariance of X comma Y, where A and B are any two real constants. Next, fourth point, covariance of X plus C, Y plus D is equal to covariance of X comma Y. Fifth point, that is covariance of X comma X is equal to variance of X, right? So this is the fifth point. Which is that fifth point? Covariance of X comma X equal to variance of X. Now, sixth one important. Sixth point, covariance of X comma minus Y, which is equal to minus times of covariance of X comma Y, right? So this is sixth point. In your mind, there may be one question arises, sir, what about if X is also replaced by minus X? What will be the covariance of C? You may face such example, I mean such question also. So this is nothing but equal to covariance of xy also, because when you take minus here, so minus minus get cancelled, right? So this is also you can consider it as a seventh point, right? So this is what summary on the covariance, right? So suppose you know all these seven formulae, you can identify or you can solve any examples on covariance. Is it clear? So now we'll go to the some examples. So we left with only examples. So now we'll go for some examples. Following is a joint probability distribution. Following is a joint probability distribution f of x comma y. So they given one joint probability distribution in terms of x and y. So here yj we have, and here we have xi. 1, 2, 3, and here pi dot, and here x values 0, 1, and x is 2, and here they given pi, sorry, p dot g. So it is 2 by 12, 1 by 12, 1 by 12, and 4 by 12. Here 1 by 12, 1 by 12, 2 by 12, 4 by 12. 3 by 12, 1 by 12, 0, 4 by 12, 6 by 12, 3 by 12, 3 by 12, right? So now the questions are calculate. First one, covariance between x and y. Second one, covariance between x and minus y. Third one, covariance between x minus 1, comma, y plus 3. Fourth point, covariance between x minus 5, comma, t minus y by 3. Right. So now we are going to find out the covariance between the given. Right. So here, solution. To find out first one, covariance of x comma y, we should know this formula, expected value of x, that is first theorem, expected value of xy minus expected value of x minus expected value of x into expected value of y. To find out this, we need to find out expected value of x as well as expected value of y as well as expected value of xy. So here, expected value of xy is equal to double summation, because there are two random variables. Xy is their expectation of bivariate case, right? Or function of any expectation. So here Pij, I running from 1 to m, j running from 1 to n, right? I running from 1 to m, j running from 1 to n. So this is what the formula we are going to use, right? So here expected value of xy equal to x values are 0, 1, 2. So first we take when x equal to 0, x is 0, y is 1, and its probability, see x 0, y 0, its probability is this one, right? So this probability is 2 by 12 plus x is 0, y equal to 2, and its probability is 1 by 2. 0 to 1 by, sorry, 1 by 12 plus x0, y3 probability is 1 by 2. 0, 3, 1 by 12 plus x is 1, y is 1, and its probability is 1 by 12. 1, 1, 1 by 12 plus x0, y equal to 2, its probability 1 by 2. 1, 2, 1 by 12. x1, y3, and its probability is 2 by 12. Sorry, plus here 1, 3, 2 by 12. Why you are taking x into y? Because we want only expected of xy. Plus x equal to 2, y equal to 1, and its probability is 3 by 12. 2, 1, 3 by 12 plus x equal to 2, y equal to 2, and its probability is 1 by 12. 2, 2, 1 by 12 plus x equal to 2, y equal to 3, its probability is 0. 2, 3, 0. So now expected value of xy is equal to, right? So here 0 is there, multiplied by this entire 0 plus here 0, here is 0 plus it's 1 by 12, it's 2 by 12, it's 3 by 12 plus it's 6 by 12 plus 4 by 12 plus 0, right? 1, 4 by 6. Sorry, it's 1 into 3, it is also 6 by 12. 1 into 3 into 2 by 6, that is 6 by 12. Okay, now expected value of xy equal to 0 plus 1 by 2 plus 2 by 1 by 12 plus 1 by 2 by 12, that is 3 by 12 plus 6 by 12, 9 by 12 Again 6, that is 15 by 12. Then 4 by 12 is total 19 by 12. We have expected value of xy, right? Just we found expected value of xy. This value we found. Now we need to find expected value of x and expected value of y also. Now to find out expected value of x equal to, we have the formula x into p of x, right? So here x values are 0 with probability 4 by 12, 1 with probability 4 by 12, 2 with probability to 4 by 12. This is nothing but 4 by 12 plus 8 by 12. This is nothing but 12 by 12, which is 1. Now to find out expected value of y, we have y value 1 with probability 6 by 12, 2 with 3 by 12, plus 3 with 3 by 12. So this is nothing but 6 by 12, 6 by 12, 9 by 12. That is nothing but 21 by 12. Now our covariance of xy is nothing but expected value of xy minus expected value of x into expected value of y. So expected value of xy, we got 19 by 12. Expected value of x is 1. Expected value of y is 21 by 12. So 19 by 12 minus 21 by 12, right? So this is nothing but minus 2 by 12. This is nothing but minus 1 by 6, right? So here, if covariance is negative, means it is negatively correlated. If covariance is positive, it means it is positively correlated random variables. You know what do you mean by positively correlated and what do you mean by negatively correlated in your previous semester? Negatively correlated means what? If one increases, another is decreases. Positive correlation means what? If one increases or decreases, other one variable is also same. It is also decreases or increases. Now, come back to the second point, that is in the second sub question, that is covariance of x comma minus 1 we need to find. What is this? In our summary, I told you here covariance of x comma minus y is nothing but minus times of covariance of y. So this is nothing but minus times of covariance of x comma y. This is nothing but minus into what is covariance we have, that is minus 1 by 6. So here what it is 1 by 6. Third point, what we want, covariance of x minus 1 y plus 3. This is equal to what? See, again by the summary, covariance of x plus c comma y plus d is nothing but covariance of x. It means that covariance of x minus c comma covariance of y minus d, everything, if the sign changes, nothing will changes here. So this is equal to simply covariance of xy. This is also minus 1 by 6. Now fourth one what we have, covariance of x minus 5 by 2 comma 3 minus y by 3, right? So here you treat a equal to 1 by 2 and b equal to 1 by 3, right? Is it clear? So now, but here b is minus 1 by 3. Why means here this is minus. This is equal to now finding equal to covariance of x minus 5 by 2 comma minus y plus 3 by 3, right? So here what we have, a is 1 by 2, just to neglect whatever the plus or minus. So this is equal to 1 by 2 into minus 1 by 3 into covariance of x comma y. This is nothing but minus 1 by 6, and this value is also minus 1 by 6. The final answer is 1 by 36, right? So in this way, we need to solve some different kinds of problems regarding covariance concept. So now we go for one more example. Example, let x and y have the joint density function. Let x and y have the joint density function f of xy equal to x plus y if 0 less than x, comma y less than 1. Next, what is covariance between x and y we need to find. This is the question. Answer we are going to find. Solution. So they given f of xy is a probability density function. It means that it is a continuous case, right? So here they given f of x comma y is nothing but x plus y, and they mentioned range of x also, right? Next, what they are going to find out? They are going to find out covariance, right? So our covariance of x comma y is given by expected value of xy minus expected value of x into expected value of y. But how to find out xy? I mean expected value of xy. Expected value of xy is nothing but double integration minus infinity to infinity xy f of x comma y dx dy. How to find out expected value of x? Minus infinity to infinity x f of x dx. How to find out f of y? Minus infinity to infinity y into f of y dy. Right? Is it clear? We need to find out. So now first we need to find out the f of x and f of y because it is a giant probability density function. So now first we are going to find out the marginal distribution of x, then marginal distribution of y. Clear? So first marginal distribution of x is nothing but f of x, right? So then how to find out this marginal distribution for continuous case? That is nothing but for I told you in our regular class, offline class, marginal distribution of x is nothing but summation x over the range space of y for discrete case. So here instead of summation we need to take integration. That's it, right? So f of x equal to integration f of x comma y dy. Suppose I want distribution of x, go for range space of y, right? So here this is nothing but integration x plus y dy. Range space of y is y less than 1. It means that less than 1 means minimum is 0. Why? Because minimum is 0, x lower limit is 0, so and it is combined function, that's why. So this is nothing but integration with respect to y here. So x is a constant, no need to take, here, plus integration of y is y square by 2, 0 to 1. Clear? Is it clear or not? If it is confusing, I will solve step by step. I hope up to here it's clear, right? So now integration 0 to 1 x dy plus integration 0 to 1 y dy. So x is independent of variable. So x as it is, integration of 0 to 1 dy plus integration of 0 to 1 y dy. This is equal to x into 0 to 1 plus y square by 2, 0 to 1. This is x into 1 minus 0 plus y square by 2, 0 to 1. This is equal to x plus 1 by 2. Why it is 1 by 2? 1 square is 1. So x plus 1 by 2. This is what the our f of x. Now we are going to find out expected value of x. Integration 0 to 1 x into f of x dx. So integration 0 to 1 x into f of x is x plus 1 by 2 dx, right? So multiply x inside 0 to 1 x square plus x by 2 dx. X square derivative is x cube by 3 0 to 1 plus x square by 2 into 2. Why it is already it is 1 by 2. So that's why 0 to 1. So this is equal to whenever it is 1 by 3 plus 1 by 4, right? So 1 by 3 plus 1 by 4, this will be 7 by 12. Clear? So this is what 7 by 12 is the expected value of x. Now, expected value of y, the formula is integration y into f of y dy. But here f of y is nothing but marginal distribution of y. So f of y equal to integration over the range space of x, f of xy dx. So this is also 0 to 1 x plus y dy, right? So when you solve this integration, you will get 1 by 2 plus y, 1 by 2 plus y. So now expected value of y is equal to 0 to 1 y 1 plus 1 by 2 plus y dy, right? So here integration 0 to 1 y by 2 y square dy. So expected value of y equal to 1 by 2 outside 0 to 1 y dy plus y square dy integration 0 to 1. This is nothing but y square by 4 0 to 1 y 3 by 3 0 to 1. So here expected value of y equal to 1 by 4 plus 1 by 3. This is also 7 by 12. Is it clear? Expected value of x is also 7 by 12. Expected value of y is also 7 by 12. Now, our aim is to find out what is our aim? Expected value of xy. So double integration 0 to 1 xy, here x plus y dx dy. How means we are using the formula in double integration g of x comma y into f of x comma y dx dy. So 0 to 1, 0 to 1, first we will multiply here x square y, x into x square y plus xy square dx dy. So 0 to 1, in y is outside. So integration of x square is x3 by 3 0 to 1 plus y outside, integration of x is x square by 2 0 to 1 dy. 0 to 1, when you put x equal to 1, this will be 1 means y by 3 itself plus y square by 2 dy, right? Now integration 0 to 1 y by 3 dy plus integration 0 to 1 y square by 2 dy. So this is equal to 1 by 3 y square by 2 0 to 1 plus 1 by 2 y cube by 3 0 to 1. So this is 1 by 6 y square plus 1 by 6 y cube. Here 0 to 1, here also 0 to 1. So 1 by 6, 1 square minus 0 square plus 1 by 6, 1 cube minus 0 cube. So this is 1 by 6 1 by 6. The answer is 1 by 6 plus 1 by 6, 2 by 6. Answer is 1 by 3. So by this calculation, what we got? We got expected value of xy is 1 by 3. Expected value of x is 7 by 12. Expected value of y is also 7 by 12. Put into our covariance. So covariance of x comma y is equal to expected value of xy minus expected value of x into expected value of y. So covariance of x comma y is equal to expected value of xy is nothing but 1 by 3 we found. So expected value of x is 7 by 12 into expected value of y is also 1 by 12. So covariance of x comma y is equal to 1 by 3 minus 7 into 7, 49, 12 into 12, 144, right? So covariance of xy equal to, when you take 144 minus 147 divided by LCM is 432. So this is nothing but minus 3 into 432. This is nothing but minus 1 by 144. Minus symbol is there. It means that x and y are negatively correlated, right? So this implies that x and y are negatively correlated, right? Is it clear? This implies that x and y are negatively correlated. Clear? So these are what some few examples regarding finding the covariance of x and y, and with some basic applied examples, right? Next session we starts with correlation coefficient, right? Correlation coefficient and some few examples on correlation coefficient, right?